Okay, now let's look at 1.2. 1.2 is basically mostly on about a and b value from the equation. So let's review again. A value is vertical stretch and vertical reflect, which is reflect over x-axis. B is horizontal stretch and reflect over y-axis. First one, consider and graph the following three functions. Y equals square root of x, general shape, alright, equals square root of x. So remember, before, in front of the square root, the negative, you always treat it as a. So for square root functions, because we were asking in the call earlier, you weren't pretty clear with it, so I'm gonna write it down. For square root functions, the formula is y equals a square root of b x minus h plus k. Remember, the k is outside of the square root. Alright, I'm sorry. I think I drank too much soda. Hi. Okay. So let's back to this question. Y equals negative square root of x. Negative is outside of the square root. That means it's the a value. Remember, if a is negative, that means there's a vertical reflect. So you would say, what if a equals negative 2? So for example, let's give like an example, all right? If it's y equals negative 2 square root of x plus 2 minus 2. How do you describe the transformations? Well, negative 2 outside the brackets. Firstly, what you see is that it's a negative, all right? Negative means reflection. And then you see the 2. What does the 2 means? The 2 means that vertical stretch. So right here in this example, there's gonna be, firstly, h and k value. It's going to shift left by 2 units, down 2 units, and there's gonna be a vertical reflect, we'll just say reflect over the x-axis, and there's gonna be a vertical stretch by, okay, remember, for A and B, you describe their transformations as vertical stretch or vertical reflect or vertical compression, or B is horizontal stretch or horizontal reflect or horizontal compression, by a factor of a number. All right, so for A and B value, describe the transformation always as something, for example, like vertical stretch, by a factor of something. So now we go back to the example. It's going to be vertical stretch by a factor of 2. Remember, that's just a way to describe the transformations. Now let's look back to this. A is negative, so it's a vertical reflect. You can just reflect over x-axis. Cute. So if you reflect it over x-axis, it's gonna go from this, see, like this is a line. For example, we have a graph like this, parabola, it's gonna go, see? This is y equals root x, so this is going to be y equals negative root of x. So now let's look at y equals negative x. The negative inside of the square root. What does this mean? Inside of the square root is the b value. So right here, b equals to -1. So remember, when we do the transformations of, or like we calculate the mapping for b value, it's always 1 over b, right? So right here it's going to be negative, you can just say 1 over -1, which is just -1. So it means there's going to be a reflect over the y-axis. So it's going to flip this way. So it's going to go like original function. It's going to go this way. This is our negative x. Amazing. Describe transformation situation, skip that. Okay, consider the graph and the following 3 functions. Y equals square root of x. I'm just gonna draw the general shape, right? Where's my pencil? Okay. This is the shape of y equals square root of x. Y equals 2 root x. Alright, it's right here. Remember, inside of the bracket, in front of the square root is the a value. It's not negative, it's positive. That means there's no reflection. Alright? Only negative means reflection. It's positive, so there's no reflection. So what does this 2 stands for? It means vertical stretch by a factor of 2. Do you want me to explain the mapping for this one? I look, you should. Okay. For I'll do it like this. Okay. For y equals negative root x and y equals negative square root of negative x. A, remember. How I remember these is that, see, b and h are both close to x, so they affect the x value. And a and k are really far away from x, so they're not supposed or meant to be with, like, they're not going to be a good couple with x, so they affect the y value. Right here, outside of the brackets, it's a equals -1, so affects, it's outside, it's not close with x, so affects the y value. So it's going to be x and -y. That's how you do the mapping. This one, b, is just -1, right? Because 1 over -1. So affects the x value. So it's going to be -x and y. Alright? Well, let's go back here. Vertical stretch by a factor of 2. How do you do the mapping for that one? Well, firstly, not close with x, so it affects the y value. So at y value stays the same. What about the y value now? So for a, for mapping, remember the formula I told you? Everything stays the same except b is 1 over b. So right here, it's the a value, stays the same. So it's only going to be x to y. What about y equals square root of 2x? 2 close with x, so it's b. So b in the equation equals to 2. What is that supposed to mean? Well, firstly, b is horizontal translations. So it's going to be horizontal stretch by a factor of 2. Wait, let me see. Yeah, by a factor of 2. When you calculate it, remember 1 over b. This is really important. So when you calculate the mapping, affects x value. So it's going to be 1 over 2x, and y stays the same. We'll just plug it in and graph. I'm lazy to do so. Let's look at these two. Describe the transformations in each situation. Consider which variable is affected in each situation. What do you think will happen in the following transformations with respect to y equals f of x? Let's see. 1 over 3, is it close to x? Not really. It's close to y. So 1 over 3 is our a value. It's positive, so there's no reflection, which is vertical stretch by a factor of 1 over 3. Second one, in the bracket, close to x, b equals 1 over 3. Well, remember, 1 over b, so right here we're going to be 1 over 1 over 3, which is just 3. So it's going to be, it's positive, so no reflection. So it's going to be horizontal stretch by a factor of, sorry, I didn't show you that. Horizontal stretch by a factor of 3. Cute. Amazing. Next page. Given the point 36 is in y equals f of x. 1. What's the new point after the following? Indicate the mapping. So first, for all of them, for all of these transformations questions, first step is always list out ABHK. Let's look at the first one. 3. Also the brackets. So it's our a value. A equals 3 means positive, no reflection, vertical stretch by, I'll say, a factor of 3. Mapping affects the y value. So x stays the same, 3y. Given the point 36, well, we plug it in, this thing, 3, and 3 times 6, which is 318. That's our new point after transformations. B, 1 over 2 inside the brackets, b value. Mapping, x, 1 over 1 over 2, 1 over b, which is just 2y. Plug in the point 36, x, wait, no, I got this wrong. B affects the x value, so it's going to be 1 over 1 over 2x, y, which is just 2x and y. 2 times 3, 6, which is 6, 6. That's our new point. For this, for the next 4, you can give it a try by yourself, but I'ma just shush for a bit, and then I'll just write out the answer. For these ones, I'm just lazy to calculate the points, so I just wrote down the mappings. AFO stands for a factor of. I'm just lazy. Why is this pen dying at this point? PMO. Okay, now let's look at example 2. Given the following graph, y equals f of x, describe the transformation of the graph gx equals 2fx. Gx equals 2f of x. And you have to sketch the graph of d of x and state the domain range. I'm gonna skip the domain range part because I think we got it. If you have questions, I don't know how to explain the domain range part, so like if you have questions you can ask Miss Lee, I guess, tomorrow. Okay, so for 2f of x, all you gotta do is just like use like these points, you just plug it in, or you just plug in the mapping. So I'm gonna just do the mapping. 2 outside the brackets, not closed with x, so effects. So it's the A. Not negative, no reflection, vertical stretch. By a factor of 2. So the mapping is going to be x to y. And then you just plug in each of these points into the mapping. Cute. 1.3.